Welcome, ladies and gentlemen. My name is Brian McLogan, and in this video, I am going to show you how to apply the sum and difference formulas. So this is the fourth lesson in our chapter for analytic trigonometry. And again, these are the notes that I taught in my classroom that I'm going to now work through to help teach you about the sum and difference formulas. So what we're going to kind of cover in this lesson is how to evaluate expressions of the sum and difference formulas, how to evaluate those expressions, or how to evaluate angles using the sum and difference formulas, as well as how to verify identities and solve trigonometric equations using the sum and difference formulas. So the way I kind of started off this class was just kind of doing a review with my students of giving them some expressions and saying, let's evaluate this, right? Let's remember the part of the unit circle because it's so important in this chapter of understanding these values. So I said, I hope you guys remember what the coordinate point here was for the 30 degrees and square root of 3 over 2 divided by 1/2, right? And just remember that cosine represented the x coordinate, sine represented the y coordinate, and remember tangent was y over x. So therefore, that ended up being, when you go ahead and simplify that, that's 1 over the square root of 3, which ended up giving us square root of 3 over 3. Okay, just something important to kind of remember. All right, so if what it is, we just kind of worked on these three problems, and most students, obviously once they kind of do a reminder, they had the unit circle next to them. We said, all right, so that's going to be square root of 3 over 2. This is times 1/2. That's going to be of 30 degrees, so then that's going to be 1/2, and then that's going to be of square root of 3 over 2. Okay, and then if you multiply those, that's going to be the square root, If you multiply those, that's the square root of 3 over 4 plus the square root of 3 over 4. Well, now I'm going to have to work a little horizontal here. So therefore, that gives you 2 square root of 3 over 4, which can reduce to the square root of 3 over 2. Okay? So again, now there's something interesting, but interesting how that simplified down to there. Then I worked on the next one. And again, we see that the cosine of 30 degrees is the square root of 3 over 2 times the square root of 3 over 2 minus 1/2 times, let's go back to parentheses. I don't know why I'm not doing that. Times 1/2. All right, I'm just going to work horizontal in this case. So actually, you know what? I should do that in the other one. Just makes it look nicer. Let's go ahead and capture that real quick. No. Well, let's see if I can do that. I wonder if it'll take that all thing. Yeah, it will. Perfect. I just kind of like that horizontally so you can kind of see what's going on. All right, so therefore, square root of 3 times square root of 3 is going to be 3 over 4, and then minus 1/4. Well, that's going to equal 2/4, which is equal to 1/2. Okay, interesting again. And then we went into the last one, which is tangent. So again, we confirm that tangent is going to be square root of 3 over 3. So if I was going to work this one out, I'm going to have square root of 3 over 3 plus the square root of 3 over 3. Not many students worked out this one. They didn't want to touch this one. Square root of 3 over 3. I'll use parentheses here to remind myself I'm multiplying. All right, now in the numerator, I can combine those. So that gave me a 2 radical 3 over 3. And then my denominator here, I'm going to have a 1 minus 2 radical 3 over 9. So one of the things we talked about, when we have something like this is we can just get rid of our common denominator here, which in this case would be 9. So I can multiply everything by 9, and therefore that obtains 3 goes to 9 3 times. 3 times 2 is 6, so that gave me 6 square root of 3. All over, let's see, that's going to be 9 minus 2 radical. Oh wait, I'm sorry. That's a 3. Jeez, I messed that up. I can't believe I did that. All right, square root of 3 times square root of 3 is 3, right? So you could have simplified that, write down the 1/3, but just to kind of save myself some space, I'll leave it just like that. So anyways, you're going to have 9 minus 3 in my case, which ends up giving you a 6 square root of 3 over 6, which gives you a square root of 3. Okay, so here's the point of doing all this. One, I wanted students to practice evaluating using the unit circle. The other thing is I wanted them to practice using operations with fractions and radicals and going back to remember everything. The other thing I wanted students to understand was that what do these have in common? Square root of 3 over 2, 1/2, and square root of 3. Well, we know they're on the unit circle, but what did they represent on the unit circle? And if you kind of notice, these all represent the cosine of 60 degrees. I'm sorry, not the cosine, that's the sine of 60 degrees. I did that in class too. The sine of 60 degrees, this represents the cosine of 60 degrees. And guess what this one equals? The tangent of 60 degrees. So what we recognize then is this whole equation. Now, again, I would never advise if I said, what's the sine of 60 degrees, that you'd write out this whole expression. But what you're going to see in this lesson is why this formula actually works. Because again, we can break up the sine of 60 degrees, as sine of 30 degrees plus 30 degrees. We can break up the cosine as the cosine of 30 degrees plus 30 degrees. So actually what these are the sum formulas for sine and cosine, as well as for tangent, which is the tangent of 30 degrees plus 30 degrees. Okay, so rather than showing you the proofs of where these formulas come from, I like to kind of use this so students can kind of see how exactly they work. But here are the formulas that my students are going to have access to. So they have them on a formula sheet. The one thing that I think that confuses a lot of students is really kind of 2 points. One is the understanding the minus plus compared to the plus minus. Notice how sine, because again, there's 6 of them, right? You have the sum of 2 angles for sine, and you have the difference of 2 angles for sine. So what this is just a condensed version of those 6 written 3 times. So that's why we use the plus minus and the minus plus. So when you're adding 2 angles for sine, u plus v, you're going to add in the expression. When you're subtracting 2 angles in sine, you're going to be subtracting in the expression. Well, that's the exact opposite for cosine. Notice cosine, when you do u plus v, you are subtracting within the expression. And again, notice that was apparent here, right? We're adding the 2 angles, it's subtraction, right? It's the difference in the expression. Whereas when we're subtracting our 2 angles, it's now going to be the sum. The other thing that's important to understand is when you are subtracting, u minus v, you're not plugging in a negative v, right? Notice that u and v are always those positive numbers. So the formula is just telling us, are we adding or are we subtracting them? But what you're actually plugging in is not a positive or a negative version of those angles. It is just the positive version of those angles. So just make sure you understand the positive or negative is going to tell you the operation, but you're going to be plugging in the value of those angles. And then last one is tangent, where the numerator is going to be the same operation as the function, whereas the denominator is going to be the opposite operation. Okay, so that is it with that. Now we just kind of get into some problems. So what I did to start off to kind of get students familiar with this is I'm going to give them this expression, and I'm going to ask them to write it as a single trigonometric expression. So basically what they have to do is kind of understand which expression I'm giving them and then determine if is it a plus or a minus. So the first 2 I'll just kind of work out because I think tangent's kind of easy. But for these first 2, I'm going to kind of refer back to our notes here. So the first example says sine and cosine, right? And then cosine and sine. So you got to think, all right, well, which formula is that? Like, is that either sine or is that cosine? And you can see, obviously, sine formula is sine, cosine, cosine, sine. And then I'd say I'm adding, and since I'm adding, then you're adding the angles, right? So all we got to do is add the angles. Now, this, the directions say simplify to a single trigonometric function and then evaluate if possible. Well, since we have an unknown here of x, we can't evaluate this, but we can write this as the sum of our 2 angles, which you can see would be u and v. So I can write this as x plus pi halves. And there you go. That's just going to be a simplified version. We can't really evaluate that. Whereas the next one, we see this one's cosine, cosine, sine, sine. So that's not the same format as this angle, as that one. You can see that's in the format of the cosine. And again, since we are subtracting in the expression, that means we're adding the 2 angles. So again, we just need to understand what our 2 angles are. And it looks like they're pi over 8 and pi over 8. So let's go ahead and combine them. So I have cosine of pi over 8 plus pi over 8, which equals a cosine of pi over 4, right, of 2 pi over 8. And the cosine of pi over 4 is going to be square root of 2 over 2. So you can see how if you actually have a value that you are aware of that you can evaluate, then you can just go ahead and evaluate it from there. All right, so now that I kind of got those out of the way, I think you can either reference them on your own, or I kind of gave these a lot to my students and let them kind of make some of those determinations on their own. So for the next one, you can see that's the sine, and it's going to be the difference of the two angles. So therefore, this one's going to be sine of 93 degrees minus 3 degrees, which is equal to the sine of 90 degrees. And sine of 9 degrees, which is just equal to 1. For the next one here, we have x and y. So again, we notice that the sum in the expression, it looks like it's the cosine formula, but it is the sum. So therefore, we are going to use it's the difference of the two angles. So therefore, this one would be written as x minus y. So just remember that cosine is like that opposite, whereas sine is going to be the same. As far as for tangent goes, it's the whatever's in the numerator what we have here. So in this case, obviously you can see tangent is completely different than sine and cosine. So we know this is going to be tangent, and it's going to be the sum of our two angles, which in this case is x and y. Now this one, a lot of students will automatically look at 44 and 1 and say, oh, 45 degrees, like I can evaluate 45 degrees. But again, notice that it's the subtraction or the difference in my numerator. So actually, as far as the formula goes, that is actually going to be the difference of the two angles, which would be 44 degrees minus 1 degree, which is, in this case, going to be tangent of 43 degrees, which we cannot evaluate. Okay, so we're just going to leave it at that. Now, eventually, we're going to get to a point where we can evaluate those with a calculator, but for this chapter, we don't have a calculator. So that's what the sum and difference angles allow us to do, is they allow us to evaluate for angles that we wouldn't be aware of. Like, for instance, if I actually were to combine these, I would have sine of 105 degrees. Now, I don't know what the sine of 105 degrees is. Like, we look at the unit circle, we don't have 105 degrees. We don't know what that value is. So what the sum and difference formulas allows us to do is add and subtract angles that we are aware of, that we can evaluate, to obtain different values like 105 that we wouldn't be able to do otherwise. And that's the same thing for radians. You can get common denominators and go and combine these, and it's going to be in 12ths, right? Which we haven't evaluated up to this point in 12ths because we didn't break up the unit circle in 12ths. So we don't have those values, available to us. So that's what that's what these sum and difference formulas allow us to do. So all we're going to do here is typically when I'll get it to my students, I'll just provide them with some angles, and then they will need to go ahead and find those points. So let's go ahead and go ahead and evaluate. So I can see it's the sum. So I'm just going to go ahead and a couple other points. One other thing I wanted to mention here too is, this could be, 60 plus 45. There's other ways though we could also do this. This also could be, we could also write this. This would give the same thing as a difference formula. So we could also do this as 150 minus 45 degrees. So the sum and difference angles, if you are just given like an angle, like 105 degrees, you could write it as a sum or as a difference, and you don't have to use the same angles. You just want to make sure you're using angles that you can evaluate on the unit circle. For instance, you wouldn't want to use 100 degrees and 5 degrees because we don't have the values of 100, the sine of 100 or the cosine of 100 as well as 5 degrees. So you want to make sure you're using angles in terms of 30, 45, 60, 90, whatever you can do that you can evaluate for. Okay, so basically though, when we are doing these, all I really just kind of tell my students is you have the formula, and all we're really going to do is say, all right, that's U and that's V, and we're just going to identify what the U and the V is and just plug them into the formula. So remember, it's sine of U times sine of V plus cosine of U times cosine of V. So you can see here, like in this case, I'm just going to break this one up slow. U is 60 degrees, V is 45 degrees. So, what I tell students a lot in this one is just plug and chug. Like, you're just going to plug it in and then chug it along. And really what we mean by chugging along, it's simplify. And that's where a lot of students are going to make the mistakes. So again, let's plug in 60 degrees in for U. So I'm not going to do this slow for all of them, but that'd be sine of 60 degrees. Oh, I wrote the formula wrong. Geez, what is wrong with me? Okay, so that's sine of U, cosine of V, cosine of U, sine of V. Weird how I did that. All right, so that's sine of U, and then I have cosine of V, which is 45 degrees. And that's going to be plus cosine of U, which in this case is 60 degrees. And then I can do that as sine of V, which is 45 degrees. Okay, so now that I've basically plugged it into the formula, now I can go ahead and evaluate. So Here's where it comes into kind of knowing the unit circle, right? And where a lot of people will make their mistakes. Even if it's, even if they know the unit circle, they'll just make them mistakes. So we have sine of 60 degrees. 60 degrees, that is going to equal the square root of 3 over 2. We have the cosine of 45 degrees, which is going to be the square root of 2 over 2. Plus the cosine of 60 degrees. Cosine of 60 degrees, that's going to be 1/2. And let's just use parentheses here. And then the sine of 45 degrees, which is going to be a square root of 2 over 2. Okay, so real quick, there's two other points that I want to make as far as how to solve these. The first point that I kind of make with these students is, you can multiply them. Like just multiply straight across, and that is acceptable in my class. So I had square root of 6 over 4 plus the square root of 2 over 4, and that was acceptable. However, on multiple choice, a lot of times what they do is they factor out the common factors. So you can see here the denominator is a 4, right? You can factor out a 4. And you could factor out a 4 here. You can see there's 2 times 2 and 2 times 2, right? So you could do it from this stage or from that stage. Now, what do they have in common in the numerator? So here, students I've had trouble students seeing that they have a square root of 2 in common here. But if you look at this last example, you can see they both share a square root of 2. So that's how I can factor out the square root of 2, which is just going to leave me with a square root of 3 plus 1. And that's it. That's basically, there's really nothing else we can go ahead and simplify from that point. So really the only, changes that we're going to have is we're going to apply different formulas and then different points on the unit circle. So when we're given these, we're going to have u and v. So you want to identify u and v. I recognize this is sine as well as the negative version. So now all I'm simply going to do is really plug these values into the formula. So to kind of skip some steps, because that was a long version, right, of me explaining, showing really everything, I'm just going to go right into the formula with the angles. So now that I'm doing the difference here, I'm going to use the sine of 3 pi over 4 times the cosine of pi over 3. Again, notice how I am using pi over 3, not negative pi over 3. The negative tells me that I'm using the difference formula, but my angle, u, is 3 pi over 4, and v is pi over 3. And then I'm going to subtract cosine of 3 pi over 4 times the sine of pi over 3. So hopefully you guys kind of see how I skipped a lot of that and then just went right into here. Now let's go and evaluate. Sine of square root of 3 over 2. That's going to be in the second quadrant. So that would be square root of 2 over 2. The cosine of pi over 3, that's going to equal a 1/2. And then minus the cosine of 3 pi over 4. Cosine of 3 pi over 4. Again, that's in the second quadrant, so just be careful. That's a negative square root of 2 over 2. And then we have the sine of pi over 3, which is going to be a square root of 3 over 2. Okay. So now, when we go ahead and multiply this, I'll have square root of 2 over 4. And then this becomes a positive square root of 6 over 4. So hopefully you can see now, again, we can factor out that square root of 2 as well as the 4. So therefore, I can rewrite this as a square root of 2 over 4 times a 1 plus the square root of 3. All right. All right, so now let's go and move on to the cosine, which is, very similar. Same kind of idea here, but now we're just going to kind of look into, using a different formula. So again, we're going to have our u and our v. So the cosine of u, just remember this is going to be cosine of 120 degrees times the cosine of 45 degrees. And then that's going to be minus the sine of 120 degrees times the sine of 45 degrees. So the cosine of 120 degrees, again, remember that's in the second quadrant. So that's going to be a negative 1/2 times the cosine of 45 degrees. That's going to be a square root of 2 over 2. And then minus the sine of 120 degrees, second quadrant. So that's a positive square root of 3 over 2. And then times the sine of 45 degrees is going to be a square root of 2 over 2. Okay, so now we can just go ahead and multiply those out. That's going to give me a negative square root of 2 over 2 minus a square root of 6. Oh, I'm sorry. That's a 4, isn't it? Minus a square root of 6 over 4. Now, again, I can factor. Notice I can factor out a negative square root of 2 here. So I'm going to factor out a negative square root of 2 in the numerator and a 4 out of the denominator. That's going to leave me with a 1 plus a square root of 3. So again, you can go back to, again, if you have trouble with the factoring, a lot of times I like to look back at that original answer over there. All right, so onto the Next one here, I have, so this is going to be my u and my v. And again, we're not using the negative v, right? This is pi over 4. So using the formula here, I'm going to have the cosine of 7 pi over 6 times the cosine of pi over 4. And then plus, right, it's the opposite sign, the sine of 7 pi over 6 times the sine of pi over 4. Okay, so the cosine of 7 pi over 6, again, notice here the cosine of 7 pi over 6 is in the third quadrant. So again, that's going to be negative. That's a negative square root of 3 over 2. The cosine of pi over 4 is going to be positive, so that's going to be square root of 2 over 2. Notice in this case here we have sine of 7 pi over 6. Again, that's in the third quadrant. So again, sine is going to be negative now too, and that's going to be a negative 1/2. So plus a negative 1/2. Again, I'm using parentheses to make sure that I do not make mistakes with these negatives. And then sine of pi over 4 is going to be a sine of pi over 4. That's going to be a sine of pi over 4. What am I trying to say? Sine of pi over 4 is going to be in the first quadrant, so that's square root of 2 over 2. Okay, so now you could factor them out or multiply them here. We give a negative square root of 6 over 4, and then minus here a square root of 2 over 4. And then again, you can just factor out a negative square root of 2 over 4, and that's going to leave you with a square root of 3 plus 1. Okay, so kind of similar result. Actually, it's the exact same result, just kind of in a different order from there. But again, you can just kind of see how that operation, how that applies for you. So yeah, it's actually the exact same answer, just flipped around. All right. So now let's go ahead and work on tangent, which again, we're going to follow the same thing. We're going to have our u and our v, and we're just going to plug them into the formulas here. Now, tangent has a little bit different take though, as far as what we did for sine and cosine. So in this case, we're going to have the tangent of u. Oops, I'm sorry. So yeah, it's going to be the tangent of 45 degrees minus the tangent of 120 degrees all over 1 plus the tangent of 45 degrees times the tangent of 120 degrees. So again, just remember that when we're doing the difference of two angles, the numerator is the same and the denominator is the opposite sign. So now we just go ahead and evaluate. So the tangent of 45 degrees, remember, is just going to be 1. The tangent of 120 degrees, again, take note of the quadrant we're dealing with. We're dealing in the second quadrant, and tangent of 120 degrees then is going to be a negative square root of 3. So again, this is me going off of the unit circle here. And then I have 1 plus tangent of 45 degrees is 1, and then we have minus the square root of 3. Okay? All right, so we can just go ahead and kind of clean this up a little bit. So I have 1 plus the square root of 3 all over 1 minus the square root of 3. Now again, we want to be careful and not say, oh, these are just going to go ahead and divide out, because they don't. You just can't divide them out because they're the same. One's positive, one's negative. But one thing that we do is we practice getting the radical off the denominator. So we're going to multiply by the conjugate. So we'll have 1 plus the square root of 3, and we'll multiply that on the top and the bottom. Now, what we recognize in the numerator is a binomial squared, right? So it's going to produce a perfect square trinomial. So therefore, that's going to be 1 plus 2 radical 3, and then square root of 3 times square root of 3 is going to be a 3. All over the denominator is going to be a difference of two squares, right? So when we multiply that, you're going to have 1 minus 3, because you can just square the first two terms and the last two terms. Now, let's go ahead and simplify this a little bit more. We have 4 plus 2 radical 3 all over negative 2, which can be simplified to a negative 2 minus the square root of 3. Looking at the next example, again, doing the same thing, we'll say that's u and that's v. And following the formula here, we'll have tangent of pi over 6 plus the tangent of pi over 4 all over 1 minus the tangent of pi over 6 times the tangent of pi over 4. Okay, so go ahead and evaluate these. The tangent of pi over 6, tangent of pi over 6, if we go on the unit circle, that's going to be a positive square root of 3 over 3. plus 1 all over 1 minus square root of 3 over 3 times 1. So you can see I'm very similar, but now what we want to do is we want to get rid of these 3. So the way that I'm going to do that is I'm going to multiply everything by 3. By multiplying everything by 3, I'm now going to obtain the square root of 3 plus 3 all over 3 minus the square root of 3. And again, you can see that we're kind of in that same boat again, right? We have basically kind of the same idea, same type of problem here that, that we had before. So I'm just going to rearrange these and then rationalize the denominator. So I have 3 plus the square root of 3 all over 3 minus the square root of 3. So I go ahead and rationalize the denominator by multiplying by 3 square root of 3. And in the numerator, this ends up giving me 9 plus 3 square root of 3. That's going to be 6 square root of 3 plus 3 all over 9 minus 3. And then we can simplify this one more time over here. So that's going to be 12 plus a 6 square root of 3 divided by 3. And now my 3 divides into both of those. And that's going to be that's a 6. 6 and 6 divides into 12. That's going to be 2 times plus the square root of 3. So you can see, again, they're very similar, but they're obviously not the same. And that's the other thing I wanted to mention. You can see how, these are exactly the same. These end up being exactly the same, but that's not really by intention or design. That's not always going to be the case. It just really depends on the problems that I ended up selecting. That is why they are a little bit different. Okay, so now let's get into... Now let's go and get into evaluating when we have a triangle. So you can see this problem's a little bit different, right? We're asking you to evaluate u minus v or u plus v, and we don't really have all the information. Like what are our angles? Like what are we adding or subtracting? So we got to remember, the unit circle is just made up of triangles, right? And remember, the sine, cosine, tangent are comparisons of sides from a triangle based on their angle. So right now we have a equation, sine of u equals 4 over 5. And what we first learned in this chapter, in last chapter on trigonometry, is we can create a triangle from there. Now we just don't want to create a triangle where the opposite side is 4 and the hypotenuse is 5, because you can see we have a constraint. The constraint says that cosine of, and that's wrong, that's u. The cosine of u has to be less than 0. So therefore, what we're going to do is we're going to draw a right triangle and say, all right, cosine is negative. That means it has to be to the left of the y-axis, right? It's either in the second quadrant or the third quadrant. Now, since sine is positive, right, that means it has to be above the y-axis. So it has to be to the left of the y-axis, and above the x-axis. Therefore, you can see here's going to be our angle. Now, we're going to use this as our u, but it's really our reference angle there. And so we'll have 4 and 5. We recognize this is a Pythagorean triple, so we'll put a 3 here. But again, most students make the mistake and they do not incorporate that to be a negative 3 because you're going to the left. The next thing we can do is look at v. V, we have a positive tangent, which is 1 over 3, opposite over adjacent, and secant if theta is positive. And again, that's v, so I don't know why I went back to with thetas. And the important thing to understand with this one is that, remember, secant is 1 over cosine. So cosine is positive, therefore secant is positive. So that means it has to be to the right. Tangent is only positive in the first and the third quadrant. So in this case, we're going to have a triangle that's going to look something like this. So that's going to be 1, 3, and then you can use the Pythagorean theorem. 1 squared plus 3 squared is going to equal 10 squared. Or I'm sorry, let's just put c squared. Or do r squared, right? So we can say r is going to equal the square root of 10. Duh. Not that. Okay, so based on these two triangles now we can evaluate, right? Because if I said, what is the tangent of u minus v? You could say, all right, so we have tangent of u, minus tangent of v, all over 1 plus tangent of u, tangent of v. So, okay, sure. What is the tangent of u, tangent of v? Like, what do you got? And if you look at this problem, what you can recognize is, by looking at this problem, we have the tangent. Like, the tangent of u is opposite over adjacent. So I'm going to just take my negative 4/3. minus the tangent of v, which is 1/3. All divided by 1 plus my tangent of u, which is a negative 4/3, times the tangent of v, which is a positive 1/3. Okay? And now it just really kind of comes down to simplifying everything. And you could do fraction operations, or you could get rid of the common denominator. In this case, let's just go and do our fraction operations. So therefore, -4, that's going to be a negative 5/3. I'm going to rewrite 1 as 9/9. You'll see why in just a second. Because when I multiply these, this gives me a negative 4/9. Right? So you want to make sure you always have common denominators. So I just rewrote 1 as 9/9. So therefore, I have a negative 5/3 divided by a positive 5/9. Well, now you just multiply by the reciprocal. So that's a negative 5/3 times a 9/5. And you can see that divides out, and that's equal to a negative 3. For the next one, again, we have the formula, right? So we'll just write this out, sine of u times cosine of v minus, keep the same sign, minus the cosine of u times the sine of v. And based on these triangles, do we have the sine and the cosine? Of course, right? So the sine of u is opposite over hypotenuse. The cosine of v is going to be adjacent over hypotenuse. Minus the cosine of u, which is negative 3/5, and the sine of v, which is 1 over the square root of 10. Okay, and now we're just going to simplify. We can just multiply straight across here. So this becomes a 12/5 square root of 10 plus a 3/5 square root of 10. Notice that I have the common denominator, so therefore I can just rewrite this as 15/5 square root of 10, which simplifies to 5 over the square root of 10, and then you can rationalize the denominator. And I'm just kind of working side vertical because I kind of ran out of space on the vertical. And then we can do the same thing for cosine. And again, it's just practice, a lot working with these formulas. So by working the formulas here, I have the cosine here of u times the cosine of v minus the sine of u times the sine of v. So again, the cosine of u here is going to be negative 3/5 times the cosine of v, which is a 3 over square root of 10. And that's going to be minus a sine of u, which is 4/5 times the sine of u, which is 1 over the square root of 10. So this becomes a negative 9/5 square root of 10 minus a 4/5 square root of 10. And now I can just go ahead and subtract those to give me a negative 13/5 square root of 10. So if you have some angles, or if you have a triangle, either one of those, we can actually find the value using the sum and difference of two angles. But the next kind of pressing point is, well, what about verifying some identities? And if you recall, verifying identities is basically making sure that the left side is equal to the right side. So typically, when we see a sum and difference of two angles, we can, go ahead and apply. You're going to want to apply the sum and difference of two formula. Now, technically in this one, we could just say this is actually an identity that we've already provided in this class. We know this is the cofunction identity. And the way that I taught the cofunction identity is you take the cosine graph. If you apply those transformations, you're going to get sine. And that works for all 6 trigonometric functions and their cofunction. So, but here in this case, what I'm going to do is basically prove the reason why this works using the sum and difference formula. So in this case, if I use the difference formula of cosine, I'll have cosine of pi halves times the cosine of x plus the sine of pi halves times the sine of x. Okay, well, cosine of pi halves here, let's go right there. That's going to be 0 times the cosine of x plus the sine of pi halves, which is 1, times the sine of x. And you can see here, that's going to go to 0, and that's just going to leave you with sine of x. So you can see how that works, right? Now, again, obviously that's an identity that I'm going to want all my students to know, but you can see how we can apply these sum and difference formulas to help us go ahead and solve. So that's exactly what we're going to do for these two. We're just going to, we see that we have the sum or the difference actually for these two angles. So we're just going to go ahead and apply the formula. So in this case, I have the tangent of 2 pi minus the tangent of x all over 1 plus the tangent of 2 pi times the tangent of x. Okay, now again, notice on 2 pi, let's just kind of do a quick little circle here. 2 pi here is going to be at 1, 0. Right, so y coordinate over x coordinate is going to be 0. So that will be 0 minus tangent of x all over 1 plus 0 times tangent of x. Well, obviously, 0 times tangent of x is 0 plus 1, and therefore that's going to just leave us as a simplified version of negative tangent of x, which is exactly what we were looking for. Here's another example, again, of cosine of pi minus x. So therefore, we can apply this, cosine of pi times the cosine of x, and therefore that's going to be plus sine of pi times the sine of x. All right, and obviously over here, this is going to equal negative 1. The sine of pi is going to be 0. So therefore, we're just going to be left with a negative cosine of x. Now what we're going to be dealing is with two different functions. And again, it's the same thing. It doesn't really matter like how many I can apply. You're just going to keep on applying them for in that case. So you're just going to now have to do this for cosine as well as doing this for sine. So I'm going to get a little bit smaller on my writing though, just to make sure I can fit everything in. But you can see how like doing everything kind of quickly or rather quickly is kind of important. And actually you can see, hopefully if you recognize actually that's already negative x. So you can kind of work from that way. But anyways, let's go and work on this. So in this one here, I will have cosine of pi times the cosine of theta plus the sine of pi times the sine of theta plus sine of pi halves times the cosine of theta and then plus the cosine of pi halves times the sine of theta. And this is supposed to equal 0, by the way. So cosine of pi is negative 1. Sine of pi is going to be 0. And then we have sine of pi halves, which is going to be a 1. And then cosine of pi halves is going to be 0. Okay, so you can see here what's going on is, let's see, that's going to 0, and that's going to go to 0. So therefore, we're left with a negative cosine of theta plus the cosine of theta is equal to 0, which of course that is going to be equal to 0. So you can see how that is verified. So that's going to be the same kind of idea here. Now we have an alpha and a beta. So we're going to go ahead and apply both of them. So in this case, I'm just going to do sine of alpha times the cosine of beta plus cosine of alpha times the sine of beta. Now this one brings in something that's really important, is the fact that, right here where this subtraction symbol, you're subtracting the expression sine of alpha minus beta. So we're going to use a subtraction. I'm going to use brackets. Okay, and I'm going to make these very big. So therefore students remember this, because if you don't include brackets, students will forget to subtract both expressions. So in this case, now I'm going to have sine of alpha cosine of beta minus cosine of alpha sine of beta. Okay, so what students do is they'll subtract this, but they'll forget to subtract that. All right. So now when you go ahead and subtract these, now hopefully you recognize that when you distribute this, and actually I'll just write this out, sine of alpha cosine of beta plus cosine of alpha sine of beta, distribute that negative to a sine of alpha cosine of beta plus cosine of alpha sine of beta. So now what you can see here is that and that are going to add to 0. These two expressions are exactly the same. So they're going to be 2 cosine of alpha sine of beta. Duh. And there you go. Okay, voila. All right, so on the last one is just going to get into solving. And, this is what we covered last class period, is basically finding the solutions, the values that make this true. And we're going to find the solutions between 0 and 2 pi, as well as all the solutions. So again, if we see the, obviously if we see the sum or difference of formulas, we're going to want to go ahead and apply them. And you can see this is pretty obvious what exactly they want us to do. So I'm just going to go into completing the sum and difference of two angles. Here are the sum for cosine. So I'll do cosine of pi times the cosine of x, and then minus the sine of pi times the sine of x. Now, before I get to this next one and do the parentheses and all that kind of stuff, I recognize this is the cofunction identity. So I'm just going to leave this as the cosine of x equals 1. Now, I'll just go ahead and simplify. So again, don't forget, like a lot of people will get this confused. They'll want to use pi halves minus x all the time. But again, that's not always going to be the case. So again, just make sure it's only cofunction identities only work when you have pi halves minus x. So, but now I can go ahead and simplify. So cosine of pi is -1 times the cosine of x. Sine of pi is going to be 0 times the sine of x minus a cosine of x equals 1. So therefore, basically, we have a cosine of x minus a cosine of x equals 1. If you owe me $1 and you borrow another $1, you have a -2 cosine of x equals 1. Divide by -2, divide by -2. Cosine of x equals a -1/2. Now, the next thing that we want to do here is, again, understand on the interval from 0 to 2 pi, when is cosine equal to a -1/2? Well, since it's negative, it has to be in the second and the third quadrant. So hopefully you're following me and you recognize those two angles to be a 2 pi over 3 as well as a 4 pi over 3. Now, these two angles do not have any equidistant between each other. So if I needed to find all solutions, I'm just going to add a 2 pi n. This would be a 4 pi over 3 plus 2 pi n. Okay. The next one is solving the equation. So in this case, we're just going to go ahead and work on, again, we don't see the sum and difference angles, or sorry, the cofunction identities. So I'm just going to go ahead and do it for both of them. So let's do cosine of x times the cosine of pi over 4 minus the sine of x times the sine of pi over 4. It's a plus, so I don't need to use parentheses. This is going to be the cosine of x times the cosine of pi over 4 plus the sine of x times the sine of pi over 4 equals 1. It's a lot. All right, so this becomes a cosine of pi over 4 is square root of 2 over 2 times the cosine of x. I'm just going to rearrange those. Minus a square root of 2 over 2 times the sine of x plus a square root of 2 over 2 times the cosine of x. And then this becomes a plus a square root of 2 over 2 times the sine of x equals 1. Okay, so we notice here we have a negative and a positive, so those are going to add to 0. Here we're going to have 2 of them, so this becomes a 2 square root of 2 cosine of x over 2, obviously, right, equals 1. Well, obviously, that goes ahead and divides out, or those divide out. So then we're left with a square root of 2 cosine of x equals 1, divide by square root of 2, divide by square root of 2. When you go ahead and rationalize the denominator here, you're going to have a cosine of x equals a square root of 2 over 2. So as far as the intervals go on the unit circle, the intervals on the unit circle here is going to be, this is only positive, so therefore this is going to be at pi over 4, and as well as in the fourth quadrant, which is going to be 4 pi, 5 pi over 4. No, 7 pi over 4. Okay, and then for B here, for B in this case, all the solutions, they don't have any intervals in common. So therefore, it's going to be set pi over 4 plus 2 pi n. And that's going to be 7 pi over 4 plus 2 pi n. If you were to look at as far as on the unit circle here, those two angles is pi over 4 and 7 pi over 4. So they're not equidistant, so you have to add 2 pi to both of them. All right, so I kind of went a little bit over on this one, so I'm going to try to sneak this one in the best I can. So let's write this a little bit smaller here. So this will be sine of x times the cosine of pi over 3 plus the cosine of x times the sine of pi over 3. And that's going to be plus the sine of x times the cosine of pi over 3 minus the cosine of x times the sine of pi over 3 equals 1. All right, so basically we're looking for what's going to subtract out now. You can see these two are going to divide out. The cosine of pi over 3 is going to equal 1/2. So we're going to have 2 times the sine of x times 1/2 equals 1, right? You have 2 of them, right? You have 2 of these. Actually, let's just go through this real quick. So we're going to have 2 sine of x times the cosine of pi over 3. Well, the cosine of pi over 3, guys, is just 1/2. So this is 2 sine of x times 1/2, which equals 1. So therefore, that just gives us the sine of x equals 1. To go ahead and find that on the unit circle, that's just going to equal pi halves, right? Which is going to be right up there. So therefore, as far as a goes, that angle is just going to be pi halves. And if I wanted to find all solutions, that angle is going to be pi halves plus 2 pi n. Because you have to keep on adding 2 pi to get to that one. All right, last 2 examples here. So again, you can see a lot of this same kind of theme going on is just continually applying these operations here. So let's kind of write these a little bit smaller so we can get to them. So we have a sine of x, sine of pi halves. And again, these are not the cofunction identities. So that's going to be, oops, writing this wrong. Sine of x times the cosine of pi halves. And that's going to be plus cosine of x, sine of pi halves, minus, so I'm going to use parentheses here, the sine of x, cosine of pi halves, and that's going to be minus cosine of x, the sine of pi halves, equals the square root of 3. Okay, so we know that's going to be a negative, so therefore those two are going to divide out. That's going to be turned to positive, so that's going to be a 2 cosine of x times the sine of pi halves. Now again, the sine of pi halves here, guys, is just going to equal 1. So that's going to give me a 2 cosine of x equals the square root of 3. Divide by 2, divide by 2. Cosine of x equals the square root of 3 over 2. And then now we just need to basically use this on the unit circle here as far as saying, all right, when is this... when is cosine of x again equal to the square root of 3 over 2? Well, again, that angle is going to be here as well as over here. So those two angles is going to be pi over 6 and 11 pi over 6. And we notice that they do not have any relationship, like they're not equidistant from each other. Yeah. So therefore, these two angles is going to be pi over 6 and 11 pi over 6. And so therefore, all the solutions is just going to be 11 pi over 6. Oops, let's just do it as pi over 6. So do pi over 6 plus 2 pi n and 11 pi over 6 plus 2 pi n. Okay. All right, guys. Last example here. Again, you can see this one's very similar. This one, again, has a cosine. Did I do one? Cosine sine? I guess I did the only one. So again, now we're just going to be doing one with a cosine here for this two different. So we'll do cosine of x times the cosine of 3 pi over 4. So minus the sine of x times the sine of 3 pi over 4 minus big parentheses to make sure we distribute correctly, right? You got to make sure you're getting that plus. And this one's going to be a cosine of x times a cosine of 3 pi over 4. And that's going to be plus a sine of x times the sine of 3 pi over 4, and that's going to equal 0. Okay, so let's go and see, let's go and see what now goes ahead and divides out. You can see when I distribute that negative, these two are both going to be 0, and that's going to be a negative 2 sine of x sine of 3 pi over 4. Okay, so now I just need to understand what is sine of 3 pi over 4. Oh, that's equal to 0, sorry. So sine of 3 pi over 4, again, that's in the second quadrant. That's going to be a square root of 2 over 2. So I'll have a negative 2 times the sine of x times the square root of 2 over 2. Now, again, you could simplify this, right? So those are going to divide out, and then you're left with like a negative square root of 2 times the sine of x equals 0. But again, what you end up with is just a sine of x equals 0, right? So now I just need to say, when is sine of x equal to 0? Well, again, we look at the unit circle. Sine of x is equal to 0 here and here, at the angle 0 and at the angle pi. We don't want to go to 2 pi because that's not in our interval 0 to 2 pi. So in this case, our angle is just going to be 0 as well as in pi. And then for b, all the solutions is basically going to be 0 plus pi n. We can keep on adding pi here infinite many times. But since we don't really need to include 0, we can just include this as pi n, right? So it's 0 plus pi n, or we can just say pi n. Okay, so there we go, ladies and gentlemen. That is everything that we covered for our sum and difference of two angles. We covered a lot of solving, getting practice using these formulas and simplifying, finding all of the solutions, going back into verifying identities, making sure that the left side is going to be equal to the right side. Was that what I was looking for? Yeah, that's what I was looking for. As well as being able to verify, or I'm sorry, evaluate trigonometric, evaluate two angles using different triangles, and as well as evaluating using given two angles that we are aware of from there. So that is everything that we have covered. I hope you guys enjoyed. And if you guys do have any other questions regarding the topics that we covered in this lesson, feel free to comment down below and I'll be more than happy to help you out. And I look forward to seeing you on the next video. Cheers.